When the world gets better, let's build a better world.
Of better values and choices.
With cleaner homes, cleaner energy, cleaner coastlines. With better products from better materials.
Using less, but giving more.
When the world gets better, let's just get better and better. Miele, immer besser.
Welcome to the greenhouse. Future food system at Fed Square. It's a beautiful day. It's always nice weather here. And I feel like we're up in Mount Dandenong because there's lots of tree pruning and branches getting mulched. So we've got Frank and Cam here who are going to be doing tours at the greenhouse. So you can book tours and get some amazing insights from an architectural point of view from Frank. Do you want to just give us a quick background?
Yeah, sure. So I'm a graduate of architecture working here in Naarm, Melbourne. And I work at a firm called McEldowie Partners, designing schools, and I teach design studios at Monash, which are all about regenerative architecture. How spaces that we design for human use and inhabitation can also contribute to regenerating landscapes and ecology.
Wow, there you go.
Wow, using your powers for good, huh?
Yeah.
And
Gotta love that.
this is the famous Cam Smith from 3RRR Eat It, a show that's been on since 1982, before I was born. And 87, is that right?
80, yeah.
Yeah.
We can say the mid-80s, that's probably a good thing. So,
Yeah.
so I've been witness to the restaurant industry, food obsessions, the way that we've grown and started to understand more and more about food and drag from all the threads of the ethnicities that make up the whole of who we are as Australians, I guess.
Yeah.
And Joost has asked me to come and be a part of this and impart my angle on this, which is food systems, how this is innovative in the way that we understand food, cook food, but most importantly, zero waste and sustainability. Using everything within a closed loop system and to say, it is possible.
Yeah.
And this is a test bed and hopefully is a thing to inspire you and all of us. Is that sort of,
Yeah.
yeah.
I couldn't have said it better myself. So here we are. What we're going to do is take you guys on a quick tour, and so you'll get a glimpse of what it's going to be like to come on a tour at the house. Let's rock and roll.
Okay.
So the outside is pretty cool. This is called well, it's a very iconic Australian finish, which is a corrugated iron finish. What makes this finish unique is these guys in Geelong have designed what's called a corner bend. And so from a bushfire and vermin point of view, corners are really difficult to resolve. They've just solved it by simply putting this corner bend.
You seen this before?
Yeah, it's amazing.
Yeah.
Incredible.
Great.
Yeah.
And so you can imagine when a bushfire approaches a house, it's looking for oxygen. It tends to just completely rip off the corrugated iron, especially on corners. In this instance, it can't get in. It's
Yeah.
also incredibly strong, and it's just one piece. So yeah, that's pretty amazing.
Yeah, because you must increase the rigidity of this so much by having the integrity in here in this shape, huh?
Yeah.
Yeah.
Not to mention water ingress as well, just from a day-to-day maintenance perspective.
Right.
Flashing and making sure that water's not getting into the building. This is a genius solution for that.
And how long has this been a reality?
So they've got a patent. So this is the first building that it was used on in a public space.
Yes.
They only released it in July last year.
Oh, so this is really new. So this is bleeding edge technology.
But the funny thing is, they tried to put a patent, or they have put a patent on it, but someone tried to patent it in 1906.
Really?
So that's how long, but they couldn't do the bend without cracking the steel.
Right.
So the genius is that they've been able to make the bend, because this is not post-painted, this is just a sheet of corrugated iron. It's a colour-bond sheet that they have folded, so there's no loss of, same with galvanised.
Oh, that's amazing.
So, do you know how they do it?
Yeah, but
They
I
have to kill me. Okay.
Yeah.
Again. He says this to me so many times. Do you know how this happens? Yeah, Cam, but I have to kill you again. How many times can you kill me?
So welcome, now you're walking in. So this is sort of like the garage. The reason why it's like the garage is because there's another door that takes you into the space. So this space gets cold in winter and warm in summer. The stairs are really outdoor stairs, but they're dry, right? So the idea is that when this gets built for my mum in Monbulk, that will be completely filled with plants. Be like an indoor garden, I suppose.
The first thing that I notice when I come in is just the thickness of this.
Yes.
This is just incredibly.
So what's amazing about these? I was at a school camp,
Yes.
and Steve was one of the parents of one of the other kids.
Yeah.
What do you do, Steve?
Yes, Steve.
I do fire doors. I sell fire doors, and I said, I've been trying to make a steel frame door because I can't stand well-insulated door systems are impossible to recycle because there's 2 or 3 different materials bonded together. It could be PVC with aluminium, or aluminium and
So,
then PVC and timber.
A composite. Yeah.
Yeah. So contamination is
Yes.
the enemy of recycling. So anything that takes a lot of labour to pull apart won't be recycled.
Gotcha. Yeah.
He said, "Oh no, I've just been to Switzerland and I'm bringing in a profile, and they've just created this profile that's 100% steel and it's thermally broken." And so 6 weeks later, there's a door lying on my. He got some in,
Yes.
and we used
Awesome.
it on the CSIRO bushfire test in 2012, and
Yes.
it's incredibly fire resistant. And so what's beautiful about it is the outside gets hot in summer and the inside doesn't.
Yeah.
It doesn't transfer. So yeah, the world's only thermally broken steel frame. I can actually show you. It's so simple.
Awesome.
Oh,
So-
great.
Oh, wow.
So it's a web. So
Yes.
what happens is the heat doesn't transfer from
Yes.
outside to inside. It does eventually,
Yeah.
but that's why they've done this design the way that it has.
And that's in there for strength.
It makes it, yeah,
The
so you can cut it,
rigidity.
you can cut it like a piece of square tube.
Yeah, wow.
So yeah, it's a really, really simple
And
system.
so there's wood behind there.
Yeah, so we've got plywood behind every single door because
Yes.
I really like the idea of screwing steel windows to timber, because this is a steel frame structure.
Yep.
But I always use timber reveal.
It's
And
better
was
for
that
disassembly.
Marine ply? Sorry, Jim.
Yeah, this is
Yeah.
all. No, this is pine.
Yes.
Came from a golf course on the peninsula.
Oh, pine, not ply.
Pine.
Got you. Thank you.
So
Sorry.
it was an 80-year-old pine tree.
Yes.
And the builder said it was like working with a really old timber because the tree had grown so slowly and on its own on the golf course. We ended up, remember Lockie getting the timber, like the chippies just said, "Can you just go to Bunnings and get a stick of timber?" "No, mate, I've got to go and ring Lockie and he'll mill it for me." So
Yeah,
he
right.
would mill the timber. So the timber was sometimes dripping. It was so wet, but
Wow.
because the tree
Yeah.
had grown so slow, it was fine.
And so this is very, very different from plantation radiata, huh?
Yeah, so there's no plantation timber in this building at all.
Yes.
There's no FSC. FSC is Forest Stewardship Council,
Yes.
which I think is the worst. It's like a monoculture forestry.
Ugh. And,
So
and
if
it's
you
Deadsville.
see all this timber here, this is all macrocarpa.
Yes.
So cypress macrocarpa was planted from about the 1850s. So what we did, right, we cut every tree down, used it, and then we brought in livestock and went, they need shade and they need protection from the wind.
From all those winds, yeah.
Yeah.
So it was a windbreak, wasn't it?
So the easiest thing to plant was cypress because you could just strike it from cuttings
Yes.
or
Right.
plant seed,
Right.
and they grew. And so
They got
that's,
huge.
that's why you go
They're
all
so
around
big.
Victoria,
Yeah.
New South Wales, you'll see them planted as windbreaks.
Yes.
Those trees are actually naturally termite resistant as a timber source, and they're mostly burned. Most farmers burn them. When they fall over, they burn them, or when they come to the end of their life, they burn them. So I'm trying to celebrate the timber. That's why you'll see it at Stokehouse on the floor and walls as well,
Yes.
using a timber that's got no value at the moment. But the reason why I
But it has got value.
absolutely,
Yeah.
it's beautiful.
It's got a gorgeous finish and also really durable as an external cladding.
Yep.
Yeah.
And smells amazing when you
Yeah.
work with it. You know?
Yeah.
And so this project is about getting people excited about agroforestry, which means farmers grow trees. And so we've done the numbers, and if every farmer in Australia planted 10 trees, we could completely be self-sufficient in timber. And not only that, the farmers actually maintain those trees. So they cut the limbs so that we get nice, big, tall, straight trees. And not all trees for cutting, but some trees for long term. So some trees might be planted to be there for the next 250 years. So like what Christy's done, plant
Yeah.
for biodiversity, plant
Yeah.
for wildlife corridors, wind protection.
Yeah.
You know, and so there's a great farm. This is how we've actually met through Christy. Her dad has got a farm in Deans Marsh, which is 650 acres, and they've planted 40,000 trees, 250 species, and only locked up 25% of their land. The average Australian farm is 4,000 acres. Chrissy's farm's 650, right? If they only plant 10 trees each year, you can imagine every farmer that I know has land that's unproductive, or that's suffering erosion or needs. So timber, agroforestry, has a massive ability to lock up carbon, to bring back habitat for birds and other wildlife. And that's what this building is trying to celebrate. We've got to get our farmers to become our future timber suppliers. And that's why the kitchen, everything is made from that tree that was cut down on a farm in Ballarat. And then the chairs are made from sugar gum. Sugar gum is an Australian native species that's endemic to South Australia.
Yep.
Beauty about sugar gum is you cut it and it regrows. You can coppice it. So you only have to plant it once. So if you plant a she oak, it takes about 25 years, say in a place like Ballarat, to get to a 30 centimetre log. But you cut it, and then it will only take 15 years to get to a 30 centimetre log because the whole root system's already there, and it just boom, it just grows, right? So you don't have to worry about keeping pests at bay. You don't have to spray. The tree will just outgrow anything, and then all you need to do is just snap off, like choose one branch, which is the Japanese have been doing this for thousands
hero
of years.
branch.
So that means that you'll never have to plant again. And
So,
it does
you know, say something like a fig tree that you cannot kill a fig.
No.
It seems, because they will always grow back and do that.
So this is like the entry, the garage. This is the reason why it's a garage. It houses the batteries, it houses the inverters. The inverter is made... Oh, sorry,
All good.
So you can see here, the battery system. So it's like outdoor, it breathes. We've also got the mushroom. This is a design that I think every house should have because every house produces a condensate. So every hot water service produces a condensate. Most families is between 20 and 30 litres of water a week. This system would be lucky to use 5 to 10 litres of water a week. And what we've done here, this is lion's mane. We've got things like sawdust, coffee grounds, cardboard, denim jeans. You can pretty much anything that's cellulose, mushrooms will transform. So what this wall does is it transforms waste into a soil, an additive to soil. And this is like lion's mane is the one that everyone's going ballistic.
Wow.
I mean, it's like a little fluffy cloud.
These
this
things
is used for
are extraordinary.
amazing to cook with.
Amazing, and it's really good for you too, isn't it?
Wow.
So these are real umami bombs.
Fuck yeah.
Smell that.
Like that's the
even
thing
raw,
that
it smells.
Matt and Joe, you know, they cook with them a million different ways, and every time it was a surprise. They're unlike any other mushroom. But this is the microdosing is all the rage in the Silicon Valley and in Australia. People are especially we had a lady here who suffered a really bad accident, car accident, and lost part of her function of her brain. And she microdoses this every day.
Right.
On this?
Rebuilding those
Not the
those networks.
not the sillies.
No.
Because I know so many people that are microdosing on psilocybin and are saying that the effects are extraordinary. You know, not. You know what I'm going to say. It's not. It's not a tripping thing. It's highly beneficial.
Well, we had another person on the tour who was saying that it's triggered all these really long-term memories. So, 6-year-old.
Wow.
When she was going back to memories as a 6-year-old, and she's taking this every day. Had been taking it for over a year, and so the memories just keep getting deeper and deeper and deeper.
How extraordinary.
So, but the point is,
How long did that take to grow? Just out of curiosity.
so it takes about 2 weeks. Ironically, this is the most prized, but it's also the easiest to grow. Usually it's the other way around, right? The stuff that you can't grow is the stuff that... so it takes about 2 weeks to inoculate the bucket.
Yes.
You hold that. I'll
Love to.
Here's one I prepared
Here's what I
earlier.
prepared earlier. Here's your mycelium.
So you can see, I was showing Frank before, there's still a bit of life left in this one. So what we do is we get one flush, which is a big flush, and then a second flush is less, and a third flush. It takes about 2 weeks for the mycelium to populate. So what we do is we put this bucket filled with organic waste,
Yeah.
in the oven
Yes.
at 80 degrees for about an hour,
Yes.
and it sterilizes the material.
Yes.
Because there's lots of airborne mycelium, fungal.
Yeast.
These species are quite weak, so the wild ones will outcompete them. So
Right.
you've got to get rid of them.
Right.
And then it takes about 2 weeks to populate the bucket.
How do you inoculate it?
Just that's enough. Like a little rice grain of it is enough.
Oh, so you could add, say, some of this.
No, so that's
No,
the flour.
that's the flour.
That you could. But
This
not
is
that.
that's the mycelium
Right.
there.
Yeah.
That's the flour.
Yeah. So
Right.
the best thing to use is a bit of this.
Right.
It would-
And then how long will it take for that mycelia to grow throughout the bucket?
2
2 weeks. Yeah.
You know, if it's really cold,
Yeah.
longer.
Right.
But so June, July, August, 3 weeks, 4 weeks.
Right.
As soon
Cool.
as it warms up,
And so here you're just regulating the amount of humidity, not the temperature.
got it. Yeah, it's we so now we'll start using pink oysters, and so we're just dealing with we're changing the mushrooms with the temperature. So when it's really
Oh.
cold, we grow different mushrooms.
Right.
When it's warm, we grow more oysters and that sort of thing. You know, but the lion's mane grow year round.
Yeah, right. So, and one of these other ones you got here, I recognise.
So
that's an
this is
oyster.
a blue oyster.
Yeah.
They're delicious. I ate some of those from your wall the other day, and I can testify that they are amazing.
Really?
Yes.
So
Some mincha? No.
pepinos,
Pepinos.
and we've got some.
I have to learn my mushrooms.
This is the abalone, which is proving to be very slow.
Yeah, right.
First time we've done this one, and which is probably it's a really difficult mushroom to grow.
Yes.
So yeah, we're quite excited about that one. But we've done about 20 different varieties, I suppose, over the last.
And has there been one that has been?
I think that for me the lion's mane is by far like you put that, you make a soup or a broth with that, or you fry it, or you know like you just peel it like layers off like that. You just fry that. Oh my god, it's delicious, really rich and great texture.
I might have to take some of that home.
You know, it's just beautiful.
Look at that.
Like little fluffy clouds.
Oh,
amazing.
And just the eye appeal of it is extraordinary.
So yeah, this is a mushroom wall, and this was inspired by my visits as a florist to Batch Espresso in Carlisle Street. So Marie, who owns Batch,
Yeah.
said, this was about 5 years ago, can you please come up with an idea for all these feta buckets? So everybody was having avocado and feta on toast.
Yeah.
And so I decided to do this. So I started getting them to knock. I made a knocker. And so they would knock the coffee grounds into the feta buckets, put the lid on, and then at the end of the week, when I did the flowers, I'd take all the buckets filled with coffee grounds back home, and I just put them in a microwave, sterilise them, and then inoculated them. And that's how it started.
Because otherwise the coffee grounds you can get that really crazy orange mold,
Yeah, which is
which
actually,
you do want or you don't want.
you
that?
don't want that.
No, that's
because it's far stronger than,
Yes.
than the ones we're growing. These are all quite weak
Yeah.
strains.
So
yeah.
what did you say this one was called again?
I actually don't know what that was called.
Oh, good. Oh, it's written on there.
Pig.
No, I don't know.
Okay.
I'll have to find out.
That's a
I haven't
pretty
grown this
beautiful.
one. Yeah.
How beautiful is that? Are they gills? They're not gills. They're sort of.
Well, they will when they open up. See how they're still
Oh,
closed?
right. Okay. Yeah. Right.
So when on Saturday, these will be completely open.
So different. Yeah. Like Slippery Jack has got. They don't really have gills. They've got like sort of little holes, or it's a different structure.
Yeah. I mean, that's the amazing thing about mushrooms. You know, they're also. I mean, there's literally tens of thousands. Where is the Australian name? Right here. This one is he calls it snowflake, but it
Yeah.
actually gets to about so big. But he found this bushwalking in Emerald and started, filling out buckets with them. I said,
Wow.
Coral.
yeah, and it fries beautifully as well. It's we don't know, like this is an Australian, no one's ever grown this commercially, we don't know anything about it.
Yeah.
But it's a native Australian mushroom.
Wow.
And
So if you're out bushwalking and you see one of these growing, you can just dig around a little bit until you find the mycelia and take it with you.
yeah, so some species
That's
will
awesome.
grow will require a bit of bark, and some
Right.
a bit of a tree, and some will grow next to it. You know, like obviously the saffron caps, you know, they require the pine needles to be broken down to a certain,
Right.
Yes.
Right.
because you can find them without the tree, which shows that they don't
Right.
require the tree to be growing in that location. So if you've
Right.
got pine needles somewhere, they'll actually grow.
Interesting.
So yeah, every species requires different. Like shiitakes grow better on wood. You can't grow shiitakes on coffee grounds.
No.
So yeah,
So can I just ask the silly question? So this is in essence a box
yeah,
with humidity coming up.
yep. So the shower, when you have a shower,
Ah.
the steam automatically goes into here and gets.
Oh, okay,
pushed
so
in
that's
here.
coming from the
And
shower.
then behind here is the hot water service, and
Yes.
that's got the water
Warmth.
gets collected.
So we've got conduction
No,
of warmth?
No, it's just about harvesting that water from the hot water service, and which gets used in here.
Gotcha.
And so if you were using like a dryer or something to dry your clothes, then they also output a lot of steam, a lot of
that's-
moisture,
it's right next to
condensation. Yeah. Aha. Yeah. Exactly.
So I mean, I've just done this, but you could enter into there. I can enter
Yeah.
into the bucket behind there too. But
Yeah.
Right.
So
Cool.
you know, obviously, for those that don't know, see the water.
Yeah.
That's out of your clothes. It's another reason why I try and convince people to get rid of plastic out of your clothing.
Right.
Use 100% natural clothing. So cotton, wool. You don't want to have blended fibers. Again, at the end of the life of the material, you can't recycle the stuff because
Yeah.
you've got cotton mixed with synthetic.
Yeah.
And so, and it's also the biggest source of microplastics in the ocean is
Yeah.
clothing.
Right.
Yeah.
Not
Right.
like every time you wash synthetic, like it's now half of clothing is made from plastic.
All right. So if you're washing or drying synthetic clothing
those
in there,
microplastics, so-
you can't use that water for this.
No,
Ah,
and so
okay.
you
Yeah.
know, it's really important that
Yeah.
we just use natural fibers.
Yeah.
If we're going to live in a closed loop system
Yeah.
where everything gets recycled back in, you need to think about that stuff, right?
Yeah.
You need to make sure that you don't use chemicals and
Yeah.
So another unique element about this house is the floor. So I'm obsessed with earthing. Earthing is when you are connected to the Earth's magnetic field. So we've always been connected to the Earth's magnetic field because we were barefoot or we were wearing leather-soled shoes. And then about 50 years ago, we invented the rubber-soled shoe. And so suddenly, for the first time, humans were disconnected from the Earth's magnetic field. What that means is that if I'm holding a charge, so a monitor, if I'm disconnected, we are a sponge for electrical energy, which is all around us, especially when we hold phones and that technology. We can't discharge.
Can't earth it. Yeah, yeah.
So I'm obsessed with this idea of earthing. So I wanted to make this house so that my mum could walk, because it would be my mum's house, that she can always be barefoot. So the floor is heated everywhere using a heat pump, really efficient. And it's also cool. So in summer we can run cold water underneath this floor. So the concrete tiles are great because they're a great conductor. They're great at transferring heat and storing heat. Got good thermal mass. These tiles are only 20 mil thick.
Wow.
And the tiles are made in Kyneton from 100% waste. So recycled concrete and recycled
Interesting.
glass. So there's no sand, there's no virgin sand, and there's no virgin cement in these tiles.
Okay.
A guy
Wow.
called John Smithwick, who's a genius,
Yes.
spent his life engineering concrete. I called him and I said, can you make 100% recycled tile? And he said, yeah, I can do that. And then put the phone down and thought, how the fuck am I going to do that? But there is a company in Bendigo that's actually crushing wine bottles and turning it back into sand.
Uh-huh.
So sand is a non-renewable resource, so
Yeah.
we can't just keep using sand the way that we are.
Yeah.
And so, we've replaced the glass with the sand with glass, and the concrete is, and so these are made in Kyneton from 100% waste. And then to ground this floor, in other words, to connect this floor to the Earth's magnetic field, all we've done is laid copper in there, a copper cable,
Uh-huh.
and then that copper cable is connected to a rod that goes into the ground. So the floor is earthed.
So it's like a copper mesh.
Yeah.
type.
Right, so you have
Lockie will remember, I was walking around with this meter while the tilers were tiling barefoot, and the tilers are like, this guy's nuts. But, you could have that copper it could be a meter apart, and it would
Right.
still be earthed.
Yes.
So the important principle is that you have a conductive connection with the earth.
Yep.
Yeah, okay.
Yep.
Interesting.
And so that's one of the reasons why you feel so good after walking on the beach barefoot, because you've just discharged all of the electrical energy. It takes about 15 to 20 minutes for you to completely discharge your the stored energy.
Wow.
And they're now realizing that there's a whole bunch of science. There's a guy called Clint Ober who discovered this about 20 years ago, and he just thought he was actually the first person to put data through a cable. So he was a wealthy man. He was retired. He's driving around, America, and then just saw all these people that had just walked out of a shoe factory all wearing new shoes, and he thought, I wonder if humans need to be grounded, need to be earthed. Every electrical piece of equipment needs to be earthed, so I wonder if humans need to be earthed.
Yeah.
So he did a really simple test on himself. He got some copper wire, put a steel rod in the ground out the front of his motel room, ran the copper wire through the window and on his bed, and he was a really bad sleeper, and he slept really well. And he thought, could that be because I'm earthed? So he did it again and again, and then he was so blown away by this that he asked some friends to do the same thing, so he set them up. And one friend had really bad arthritis, and she woke up without arthritic pain in her hand.
Wow.
And she said, it's got to be this.
Wow.
So then he went to a library, he couldn't find anything. The only thing he knew was that Native American Indians would create a hole in the ground if you were sick and would bury you in the ground to recover, to be connected to the earth continually.
Wow.
So he knew that there was an indigenous knowledge of the healing ability of the earth. Anyway, there's a great film called, what's it called, Lucky? Earthing. The Earthing movie. And it's about Clint Ober.
Cool.
Some guys that actually came to have lunch at my place about 6-7 years ago, Josh and Rebecca Tickell, made the film. And I think pre-COVID it had like 200,000 views, and now it's got something like 50 million views.
Wow.
It's gone viral. It's great. It's a great film. On YouTube it's free.
Cool.
And it's all about earthing and the fact that you can't have inflammation if you're grounded.
What's it called again?
The Earthing movie.
The Earthing movie.
Yeah, I'll send you a link.
Please.
But yeah, it's impossible for inflammation to occur if you're earthed.
What?
Wow. Because inflammation is the cause, or like a catalyst of so many other problems.
Yeah.
Everything pretty much.
Yeah.
Yeah.
My
So
God.
it's really important.
Yes.
So that's the floor.
That's the mushrooms.
That's the mushroom.
Now we've got the power systems that we've. Now we've had a look at the windows.
Yeah. So
And we've talked about what's in these walls here a little bit. We could probably do a little bit more on that.
Yeah.
the battery system that we were going to use.
Should we close this door so we can get a better look at them?
Sure.
Come on in, Jack.
So we messed around with two systems. So I'm quite obsessed. So this is called an Edison battery.
Oh, yes, what did you...
So this
Cool.
battery is 100 years old,
Yes,
and it still works. And the beauty about, so I'm
Wow.
obsessed with circular economy. So for me, if we transfer everything that we do to following a few simple rules, if it can't be recycled, don't use it. We need to follow nature's rules of like a circular economy. So everything recyclable.
Yep.
This battery can be recycled, but you probably won't need to recycle it in your own lifetime because the batteries last over 100 years.
Yes.
So Edison won the 1,000-mile challenge in 1910 with his electric car. He beat all of the petrol-driven cars with an electric car on the 1,000-mile challenge
Wow.
with this battery.
Wow.
I mean, there were lots of these batteries on the car.
Yeah.
But that's how long the technology's been around. Lots of people say it was Rockefeller that ended up convincing, because Henry Ford was, Edison was a mentor to Henry Ford. And lots of people say, Rockefeller's offered Henry Ford more money to put the petrol engine in. I believe it's just because the infrastructure didn't exist. Like we ran enough electricity to a house for a light bulb, not to charge a car, you know what I mean? So the infrastructure wasn't, the idea was too early. Whereas today, we've got all this infrastructure, our energy consumption is plummeting. It's the perfect time to release an electric car.
Yeah.
You know, we're all got power to our houses, but like Victoria since 2015 have increased its population as a state by 500,000, but our energy consumption has dropped by 54%.
Wow.
Yeah. So we're massively reducing our energy requirement.
Wow.
And that's because, you know, a heat pump uses 80% less energy.
LED
light globes. An air conditioner that you buy today from Mitsubishi uses 75% less energy than a Mitsubishi air conditioner from 6 years ago.
Yeah.
So you know, we are massively, and I think we're only scratching the surface. I think we're going to have a huge energy oversupply in a very short period of time. I built my house in 2006. There were 64,000 houses with solar. We've just surpassed 3 million.
Wow.
The market speaks.
Yes,
That's
Australia
huge.
now. Australia has, to be honest, always had the most houses covered with solar on it.
Yeah.
But now we are really like scaling that, and so it's just perfect timing. So
What's the makeup of this battery
so,
again?
so this is called a nickel iron battery, and it's basically iron plates covered with nickel, and that's and the electrolyte inside is what do you call that? So you can actually, so it's the acid that comes out of the battery is toxic. What comes out of this battery you can actually use on your garden.
Wow.
So that's one of the other reasons why I loved it. I mean,
Yeah.
I was reading stories about how people were using it as a fertilizer and all sorts of stuff. But actually, if you use it pure, you can actually kill weeds with it. But then that becomes food.
Wow. Cool.
So we had a battery system here
amazing.
set up originally, which was a 100% nickel iron battery. I'm trying to convince people to invest in setting up a company and start making these batteries here in Australia. But the problem with them is they have a memory. And so you need to constantly use them. So they're bulletproof, you can't kill them, you can't damage them,
Yes.
but they're not that agile. So let's say you've got a beach house and you go there once every 6 weeks and you turn everything on, they won't work. You need to, they've got a memory. You need
Right.
so you need to leave the fridge on, you need to leave your lights on, these batteries need to be used.
Right.
Yeah.
And so for us here, when we were starting to have guests in, there wasn't enough. So I'm actually installing these ones in my house, these nickel iron batteries. And so what we ended up using is this Gen Z battery, which is an Australian designed battery that can be recycled. So this is a lithium-based battery that can be recycled. So it's designed with end of life.
So this is the same technology that's in our phones.
Yep.
A lithium battery, yeah?
Yep. And this is Cellectronic. Actually, Lockie just builds a container with how many?
There is 80 of those
Yeah, huge.
in the 20 shipping container. We'll have enough energy to power 10 houses.
Cool.
Yeah, I mean, this is crazy, right? So this pretty much, if every house had this system, you can be off grid. We're off grid here. So you can see here, we're almost full, and we've still got, we've got one bar to go, and I've got the dry, not the dryer, but I've got the washing machine going.
Yes. Yeah.
It's pretty much designed to have a small family. This house.
Yeah.
This inverter is made in Chermside Park and owned by a family, Cellectronic. They've been making inverters. It's the longest running inverter company in the world. They've been making inverters since the late 60s and they're regarded as the best inverters in the world. And then this material here is incredible. It's called magnesium board.
Magnesium, that's right.
It's basically made from magnesium.
Yes. But not the burnable type.
The Romans used it.
Yeah.
It goes back a long way. So the Romans used it to line their ovens.
Is this magnesium or magnesium oxide?
Magnesium oxide.
Yeah, because that's the important bit.
Yeah.
Yes.
And it does have a little bit of sawdust in it to bond it. It's 5%.
Yeah.
I was first told about this material in 2006 for my house, but I couldn't buy it anyway. In China and Canada, it's a really ubiquitous building material. It's very cheap. It's naturally mold resistant, naturally fire resistant.
Why is it not available here?
Don't even go there. So,
I don't
if you
know.
remember the fire test that I did in 2012, that had magnesium oxide.
Yes.
On the
Right.
outside.
People just go like automatically for cement sheet when they're specifying products to use in this kind of application.
Yeah.
Yeah.
The reason
So,
why it's got
yeah.
such a low carbon footprint is because it's cured at room temperature.
Right.
Whereas cement's made at 1600 degrees, so there's a lot of energy that goes
Yeah.
into curing it.
Yeah.
But also, fibre cement can explode when there's a fire. It
Right.
gets to a point and it actually just explodes.
Really?
This, like, it can be 1,000 degrees for 3 minutes.
Yes. Yeah. Whatever.
Wow.
Yeah.
Cool.
So, still hoping that,
So where did this come from? Yost?
China.
China.
Yeah. So now, let's go to the bedroom.
Before we move on, the other question that I had, because we're talking about building materials, is the steel frame and the steel that's in the walls.
Yeah, so all my buildings are steel frame. I've never used a timber frame, and that's because I don't believe there are enough trees on Earth to be able to sustainably supply timber. So I know all the arguments about carbon, the carbon that gets locked up into buildings. Problem is that the timber's coming from a system that is incredibly destructive.
Yeah.
So the current forestry system is something that I cannot stand. It's worse.
Yeah.
And it's a worse form of monoculture. Like monoculture of wheat or corn is only one season, right?
Yep.
A monoculture of a timber you're locking up an area for 20, 30 years. So if you've got like one species, let's say it's radiata pine, it destroys that ecosystem. So the way that
Completely. You walk in a pine plantation, you guys know it, you hear nothing.
I've been through plantation forests in Sweden, New Zealand, South America, Europe, Australia.
Yes.
You don't hear birds, you don't see wildlife, unless you get into the edge of the forest.
Yes.
Where that's when you start to hear birds. And so I can't support that because it's just the opposite of what the world needs. What the world needs is biodiversity.
Yeah.
And so that's why I'm such a huge fan of getting our farmers to start planting different species, wildlife corridors, and planting for future timber, you know. And the beauty as well about steel is it follows, like steel is the easiest material in the world to recycle. Magnets pick it up.
Yeah.
Yep.
So even if you throw steel, a can, in your rubbish bin, not in your recycling bin, it gets recovered.
It can be found.
Because they...
And pulled out.
Yeah, they roll over it with magnets, and it just gets... So it's a really easy material to recover. It's incredibly strong. Almost all my buildings are light gauge steel.
Yes.
So light gauge steel was a... you might see the blue frames that you see, the housing systems. And that was actually invented in the 70s by an Adelaide engineer, adopted by BlueScope, which was BHP at the time, and became not really that popular here because people were still obsessed with timber, but became really popular in New Zealand. So there's a great little company called Howick Engineering. I went and visited the two brothers they're about 2 hours outside of Auckland, and they started making the world's best roll formers. And so I used these roll formers to make the first 4 greenhouses. And what it does is it's like a roll of toilet paper. So you get like 1,000 kilos of steel on a roll, and you put it in this machine, and it forms a stud. And
cool.
Howick made these roll formers, but the reason why New Zealand became so excited by them was because they suffer earthquakes. And steel buildings are much more resilient to earthquakes. And so
because of their non-rigidity, or
so
there's
like
a
let's
flex
say the greenhouse in Sydney at Circular Quay had 80,000 screws, so it's like a Boeing 737.
Yes.
It's all the rivets.
Yes.
Incredibly light for what it is, but it's all the rivets that make it incredibly strong.
Yes, they give it the structural integrity.
Yep. And the beauty about it is termites can't eat it.
Yeah.
So you're not using a lot of steel to get in a minute. So the Sydney greenhouse had, I think we used 13 tonne of steel, and that steel actually came from India because I wanted to make the steel from 100% recycled coil. And the only company in the world that was making 100% recycled coil was in India. So the greenhouse in Sydney was made from 100% recycled steel as well.
Right.
So we used 13 tonne of coil, and the building was 200 square metres. We were allowed to have 150 people on the roof, and it had 60 tonne of soil on the roof.
Wow.
13 tonne of steel to make the whole skeleton.
This is the architecture person doing the proper correlation. These are just figures to me, but I can tell from you that's pretty amazing.
Yeah, I'm pretty sure that, like I work with Arup on that, I'm pretty sure that that was the lightest steel building, lightest and strongest steel building ever designed. And we built it at Circular Quay, opposite the Opera House there, on the stairs. We had the roll former delivered.
Yes.
And the coil delivered. And then we rolled and made that whole building on site.
Wow, cool.
Is that the one, did you transport that one to Melbourne for the, or that was another one?
That was another one, yeah.
So the roll forming machine's not big?
No, the roll forming machine is about 90 centimetres wide and about 3 metres long.
Oh, wow, that's cool.
And then the decoiler is a separate unit that sits behind that. It's
just like a roll, really, with
And
That's
it's
amazing.
incredible, right? Because the technology today is, I know exactly how many, like the building is, I know exactly how much weight it will carry. I know exactly how many screws I need, how many kilos of steel. So there's no waste because it covers 1,000 meters. So let's say you make a truss. It's prints on there, top chord, bottom chord, side flange, and cross, and they're all numbered and printed on. Plus the holes are already pre-punched.
No way.
And they're dimpled so that when you put plasterboard, it's flush. So the screw head doesn't.
Yeah.
This is all Australian.
That's great.
Invented in the
Close your
1970s.
mouth, Cam.
Yeah.
But the New Zealanders were the ones that really took that technology and pushed it. And now Istanbul, Italy, like the
Yes.
places that suffer from earthquakes, are all adopting this steel technology. Use a lot less material. And it basically makes the skeleton of the building endlessly recyclable. So if the building lasts 200 years, in 200 years' time, that frame will still be valuable
Yeah.
and will be very easy to recover.
That's the other great thing about steel is that the durability. But the unanswered question is how much energy is used in refining steel and recycling it, melting it down and then redoing it. But there's lots of companies now, well there's a few companies in Australia that are looking at doing that with hydrogen.
Yep.
And so if you can produce your hydrogen using solar power or wind power or some kind of renewable energy, then you have a closed system.
Yeah,
Yes.
and I you know,
And
I
that's
know,
possible now?
I know that Australians think that they're like, I know that Andrew Forrest is looking into it, but to be honest, the Indians have already, they're doing this,
Really?
and they are really excited, but they're just not very good at telling that story.
Right.
So why
So
is
right.
Andrew
Sustainable.
Forrest on a jet to Mumbai or somewhere wherever in India to
Well,
have
I think
meetings?
Andrew knows that the future, like
Yes.
it needs to be green, and
Yeah.
I personally think that technology will solve itself very quickly. I'd rather have
But what you're saying is the answers are already there
yeah.
in the northern hemisphere on the subcontinent.
Well, I know that in India they've been working on sustainable steel for a long time, and Mittal, who's a billionaire that now lives in London, that's been his goal for a long time to have sustainable steel. From, you know, he's more interested in recycling what we already have, not digging it out of the ground.
Yeah, that's good. That's really good.
But yeah, I think that those problems will be solved.
Yeah.
My concern is that there's now young architects are so obsessed with timber because it's been like the timber companies have been so amazing at marketing it as sustainable. What people don't understand is that there's 100 trees being cut for every one tree that's being replanted. We don't have enough trees in order to be able to house the world's population.
Yeah.
And so we need to start planting, and we need to start planting for biodiversity, and we need to, you know, I think timber needs to be where we touch it. Things like stairs, furniture.
Yeah, touch points.
And-
And aesthetic too.
Yeah, because another thing that Australia suffers is termite.
Yeah.
So I'm obsessed with the idea of organic buildings, organic houses, organically certified houses. Termite treatments will not meet organic certification. So you
Yeah.
have to go for a steel frame if you wanted to build an organic house.
Yeah.
And then it's like a friend of mine Ward Pepperidge, who's got this incredible recycling company called Waste Converters down in Dandenong. He's been begging the EPA and everyone for 20 years, we need to stop using termite treated timber because it comes into his yard. He recycles timber and turns it into pallets and all sorts of amazing things. Violins. He's got this thing called Create from the Crate, where he gives $5,000 rewards to people that design all this stuff. But the problem is, termite treated timber needs to go to landfill because it's hazardous.
Right.
It's all the creosote.
Yeah.
And so also when people work with it, it makes them sick.
Yeah.
It's toxic. Like
You
even termites.
smell it. You cut the stuff, you smell it, you go,
Yeah. So we just need
That's
to
not right.
eliminate that shit out of our lives.
Yeah.
Yes.
And that brings me to our plumbing and electrical. Because another material that I cannot stand is PVC. So this is a PVC-free house, apart from this pipe that John, our mushroom guy, put in when I wasn't here.
Yes, when he was
Why you weren't
You
looking?
can see there, I've used copper and what's called gerbera, which is polyethylene. So Switzerland has banned the use of PVC for over 20 years
Really?
for potable water.
Right.
Because it leaches
Yeah.
and it's toxic.
Right.
I'm more interested in the fact that it's not recyclable. PVC is impossible to recycle. So it's toxic to people that work with it. It leaches into your waterways. it's a carcinogen. We know that it's a carcinogen, like the people that manufacture it, the warnings are on the sign. So we know that we're running water through carcinogenic pipes. So this building is PVC free and we've used polyethylene. The beauty about that is it's made from recycled plastic and it's recyclable. And what plumbers do when they join, so why should, in my opinion, someone ultimately get sick because they built you a house? So what do plumbers do? They join pipes, and when you join a pipe, you're doing it like this because you want to see what you're doing.
Yeah.
So you're over it, you're breathing it, and the glue that you use.
That blue shit.
That blue glue, yeah.
That blue stuff which melts
Yeah.
and forms a vapor. They use, and
Yeah.
it's stinky.
It's
It's
the
so.
same with Caesar stone, silicosis. It's like
Yeah.
Oh, yeah, right.
we,
Yes.
we just shouldn't use materials that make the people that work with the materials sick.
Yeah.
That's my philosophy.
Yeah.
Yeah, but our workforce is expendable. He goes. I'm just there you go. I was just saying if you're paying attention.
So
I was
we-
being ridiculous devil's advocate.
We have electrical cables that are coated in non-PVC, and we've got plumbing that's non-PVC. 10 years ago when I did the greenhouse in Perth, we did that PVC free. It was a nightmare. You couldn't get the materials. Now you can go into any Reese and get a replacement for any PVC part. There is no need anymore to use PVC, so we can eliminate it. And it's not more expensive either. So there you go.
So
so-
namely the polyethylene is the same price comparative.
Price competitive,
Yeah.
and you don't use glue. So
Uh-huh.
what you do is you'll see the two.
Yeah, they're clamped.
You see the little yellow tab that's sticking out? So what you do is you put two electrical nodes on,
Yeah. Oh, yeah, I can see the
and
little
then
one.
when it melts the two. So there's little bits of copper in the plastic, embedded in the plastic. They heat up and they melt the two materials together.
No way.
When that little tab pushes out, you know that it's bonded, and you can move on to the next one.
So how
Wow.
do you heat it up?
That's cool.
Just with an electric, you basically put like a positive and a negative on it. So that's what those two tabs
Oh
are
my
for.
god.
You stick them in, and then it's quite quick. It takes about, what is it, Lockie, 10 seconds? 15 seconds. Yeah.
That's
Cool.
extraordinary.
Cool.
Have you seen that before?
No, I haven't.
So yeah, in Switzerland they've been using it for 20 years. It's all Swiss, but that's all made in Melbourne.
Yeah, right.
Swiss company made in Melbourne, Gerber.
Cool.
So we're going to the bedroom.
FYI, that's 40 minutes, guys.
Yeah.
Oh, really? Wow, God.
Wow. We're still in the first room.
Jeez.
Yeah, yeah.
Yeah. I need to get all this stuff written down, all the names of the companies and things.
Yeah, I can.
So,
Awesome.
what we'll do is we'll go, Lockie, we'll go for another 10 minutes, and then I'll do a live stream,
Yeah, okay.
and then
Yeah, because you're 10 past 12.
and then we'll do one that as I would normally do it.
Yeah.
Okay.
Cool.
So, what you see here is best material in the world.
Yep.
So the most wasted resource on earth is straw. So for every kilo of oats, barley, wheat, rice, we produce a kilo of straw. This panel is made in Bendigo from compressed straw. And so most straw today is still burned. We should be using it for paper and cardboard. It takes a lot less energy to make paper out of straw. I mean, papyrus comes from straw, the stalk of the straw. the worm.
Right.
And so you can imagine in some places like Bali and in China, they have 4 crops per year.
Yes.
Rice, wheat, barley, That could all be going into building materials, but it could also be going into paper. So this company called Durapanel have been making this panel since 1956 in Bendigo.
Oh, that long?
Yeah.
Really?
And it was originally invented in Sweden.
Come right here, buddy.
And
You can really get a feel. There you go.
yeah. And we've actually, if we go into the bedroom,
Come on. Wow, nice colours.
Gorgeous.
so you can see here, this is what's called biochar.
Oh, yes.
So what we did is we turned the sawdust. So Andrew Aramore saved all the sawdust from the kitchen and used it. We made biochar out of it. So a friend of mine, Russell Burnett, we've been mucking around for about 20 years.
Yep.
So when I was in Cuba about our honeymoon 20 years ago, I found out that the Cubans use charcoal to control golden staph. in hospitals and airborne viruses. So they have little bowls of charcoal in every room.
Oh, interesting.
It just blew my mind. So I started to muck around with biochar. I actually flew to China in 2010, and with 60 kilos of biochar that we made from olive pips,
Right.
went to a magnesium oxide factory and we put it into the sheets of magnesium oxide in China because I wanted to create a material that was constantly absorbing toxins and
Oh,
pollution.
yeah, of course. You're right.
So
Amazing.
in the straw panels here, we've embedded 300 kilos of biochar. So it's and we are now testing to see whether that wall will actually absorb the coronavirus as well, because we believe that that wall, because it's porous, it's not sealed. There's no glue or anything in there.
That's what I was going to say. It is porous.
Yeah, and so the biochar will constantly keep absorbing pollution.
Amazing.
And what sort of ratio biochar to straw are you doing?
We're doing 100 grams per square meter.
Yes.
Just made that up, pulled it out of thin air.
Yes.
1 gram of that biochar has been tested, and 1 gram equals 275 square meters of surface area. So 1 gram is about that.
I wanted to see those eyebrows come together because I don't understand.
So that's about a gram, right?
Yeah, it's a gram.
Maybe.
And how do you translate that? You said then you translate that.
So if you put that under the microscope, what you see is a sponge. It's completely porous.
Right.
Some charcoal can be 1,000 square meters per gram.
So if you unfolded that surface, that's what you're saying, that it would cover that area.
Yep. And that's why it's so valuable, and that's why they use it in hospitals in Cuba. And this idea goes back thousands of years. It's not a new idea. Like it's a magnet for pollution.
Can I go back one more step? Sorry, and maybe.
It's under a microscope.
Oh, right. Wow.
And sorry, one more. Oh wow, look at that. And how is this produced again?
So this is burned in the absence of oxygen.
Yes.
And a friend of mine happens to be, he was a wheat farmer, Russell Burnett.
Yes.
And there was a documentary about 25 years ago on TV called The Black Soils of the Amazon, Terra Petra. And he was a wheat farmer. And he knew that when a tree burned to ash, the crop would be the same. But when a tree burned and there were lots of charcoal, the wheat could be 1 meter high, and he'd have to slow the harvester down where the tree was the previous year if he burned it. So he knew that charcoal was valuable and ash was not. And so when he saw this documentary, he thought, oh my God, this is so good for Australian soils. Like Australian soils, we could just be turning our straw, our wood chips into charcoal, embedding it into the... So he started making his own pyrolysis machines. In the end, he became a worldwide expert on it. He totally sold his farm. He's got pyrolysis machines in Atlanta, in America, in Sweden at universities, all made in Bendigo. And we became friends. He actually made a ton of charcoal for the first greenhouse in 2008, which we put in the soil. So it's really valuable in soil because it's air.
Yeah.
The most critical thing in soil is air.
Yeah.
It's not nutrients. It's not like air. Biology in soil can't exist without air. So the biology that we rely on, and that biology that actually breaks rock matter and material down that makes the nutrients available to plants, relies on air. So the problem with soils is, and that's why heavy tractors and compaction, airfill porosity is number one, and that's why. And this will be air for the next 100 years, 1,000 years. Like they still find black bits of charcoal from 2,000 years ago in the Amazon. So it's got a very long life. So we put a ton into all the soil. And we put 300 kilos into the walls. And it all came from the sawdust from the kitchen.
Wow.
This is a grow bed. This is inspired by my friendship with... these top 2 plants need a bit of a water. You can see I haven't been here for a few days.
Yep.
Inspired by my friendship with Zach Bush, who is an expert on cancer. And so a friend of ours suffers... her breast cancer came back twice. And so when I met him in New York, I was doing some zero waste dinners with the team from Silo in London, and they said, do you want to invite someone? I said, I'd love to invite Zach Bush. He's a hero, you know, this guy's a legend. And they contacted him, and then we hooked up, and that's how we met. And then I actually brought him out here, and he did a talk last year as Deacon Edge. Zach and his team discovered that plants exude, well, actually, no, I'll step back. Was an Australian scientist that 20 plus years ago discovered that plants, it's the soil that absorbs pollution, not the leaves.
Oh, really?
So she did a very simple test. She had 2 boxes one had the whole plant and the other one had the leaves outside of the box. They injected formaldehyde and benzene into the box, which are the two most problematic airborne toxins.
Right.
Both plants absorb the same amount of airborne toxins. She was the first person on earth to actually prove that it's the soil and its biology that absorbs toxins, not the plants. But of course, you take the plant away, and then you don't have the symbiotic relationship in the soil that produces all that stuff. So that led me to do that vertical garden with all the pots, so that if you've got that in your house, you're creating microflora. So this particular plant, this is turmeric.
Yes.
This will create a biology that's airborne, and it can be up to 1.5 to 2 meters away from the plant. So the reason why I've got so many different species of plants in here is because you get a whole different microflora. So when you're sleeping, you're breathing in the biota, that biology that goes back millions of years, that is soil biology, and that's what that does is it shrinks cancer cells, and whatever you breathe has a massive impact on your gut microbiome. So the air that you breathe and the biology that you breathe can change your microbiome. So often these things are caused because we don't have a good biology in our gut. Breathing in all the different, like there's some ferns in there that go back 300 million years. So the biology that's in that soil is 300 million years old.
Okay, yeah, that makes sense.
So if we had a microscope that could see all the different species of bacteria that are in the air and microflora, that would all be emanating from this bed. And that's why I think sleeping on a grow bed is like the future.
That's
Because
awesome.
Then, it's like waking up in a rainforest.
I have so many plants that I grow in my house, but none of them are close to the head of my bed like that. Now I'm thinking I might move something.
Yeah, I think we might have to.
Yeah.
And the monstera that always tries to take over the world.
Yeah.
And this light is a bit of an iconic thing.
I love these.
I made the very first 72 for the when Heidi rebuilt opened their new museum. And they commissioned me to create an installation for the opening night. And I did some research, and the Reeds bought Heidi as a dairy farm. Originally it was a dairy farm.
Okay, yeah.
And so I used this dairy wire to make 72, because it was 72 years since the Reeds bought the farm.
Yes.
And I made 72 lights. And so they became a bit of an icon, I suppose.
These
curtains are made from felt, removalist felt.
Yes, I
Again,
love those.
No synthetic materials. So Carla and Eddie Maguire were, I was doing flowers for them every week. And Carla explained that a log fell out of the fire, and within 30 seconds the whole house was on fire. And so I started looking and researching and realizing that carpet, underlay and rugs and curtains all are interwoven with plastics and synthetics, and so I thought, right, when I build my house, I'm only going to use natural materials. So this is just wool.
Was this expensive?
I got Monbulk Rural to make these for me. So Monbulk Rural do all the bird netting for the orchards and the vineyards.
Yeah.
So they made them for me.
So the answer is no, not really.
Yeah.
Not expensive.
No.
I have a
friend that's selling her own at the moment.
I have a jacket that's it's a bluey, like an old firefighter's jacket, and it feels like a really similar material.
Yeah, so this is just a B grade wool, like the wool that's not good enough to go into clothing. So that's what they use for removalist felt.
Right.
J&J
awesome.
Davies.
J&J Davies.
I love the red stitching's nice.
Yeah,
this was all wasted, so that's why some of it's blue, and I just said use whatever you've got.
But it's great. I mean, it's beautiful.
How are we doing time-wise?
It's valid. Oh, we've been an hour and a half.
No, 54.
Okay.
Cool. So
this is good.
Someone in my office, I heard them on the phone about a week ago talking to DuraPanel, and they're speccing it throughout an entire school that we're building. So
oh my god,
it was really cool. I was like, DuraPanel.
get them to ask them to put because it also makes it stronger.
Right.
With charcoal in it.
Right. Yeah,
So
I'll have a
let's
chat
set
to
up
them
a
when I go
whole
back to the
system.
office. Yeah.
So let's go upstairs.
So they'll know. She just says on the phone to them, we want to put the charcoal in.
Yeah. Just
Awesome.
say, the roasting.
Cool.
So this is the kitchen. Oh wow.
Gosh.
There's a lot, isn't there?
It's unbelievable, isn't it?
So I'll just go outside, lock, and I'll just open the window if you stay there. Yeah.
Cool.
You guys stay inside and I'll stay.
I started growing kangaroo paw in pots in my house, and it actually works.
It does?
It works as a potted plant.
There's
Yeah.
some beautiful kangaroo
house plant.
paw as you walk into the gallery,
Yeah.
which I used to show to, those American tourists I was talking about.
Yeah, it's alien looking.
Oh my God, they're so crazy.
So I suppose the intention with, like, ever since I was a kid, I've had this dream that every house is productive, right? So I really believe that forever we've been in our food system. So for hundreds of thousands of years, or possibly 2.5 million years, humans have been in their food system. They've woken up in it, they've lived in it, they've relied on it, and they've been part of it.
Yes.
And for the last 100 years, we've done everything we possibly can to remove ourselves from
Separate
our food
ourselves.
system.
Yeah.
And that, I think, is detrimental to not only our health, but it's detrimental to our mental health. And so the idea with this building is that you wake up and you're in your food system. The first thing you see when you walk in is the mushroom. And then you walk, there's fish here, and there's yabbies, and there's mussels, and there's food, and there's bees. And this house is only 87 square metres of footprint, so it's like about a quarter of the average Australian family home. But I think that it's kind of proven that you can grow a shitload of food, and it's a very different, very different when it's designed so that you get constant access to vitamin D. Sunrise is there. We've got solar panels that face the sunrise. We've got solar panels that face the sunset. But not only that, we get vitamin D.
Yeah.
So in a place that's designed like this, you're always outside
Yeah.
because it's just so easy to be outside. You're not walking around to the back of the corner to the veggie patch. This is the veggie patch.
Yeah.
So you're like, the raspberries are ready. I'll go and put some lemons, or I'll go and collect some honey, or go and feed the fish, or.
So, how many people you could support a family living in this home off the food that you grow here?
Well, we had Clive here last week, and he believes you could supply a couple of families.
Two families.
Two
Wow.
families.
Wow.
Wow.
Yeah, so they did a whole bunch of research, which actually inspired this project as well. A book where they fed a family of 30 square meters.
Really?
So this is 80 square meters.
Wow, that's nothing.
Yeah. So just kitchen. All the tapware made in Melbourne from 100% recycled brass. Sussex Taps, one of the most beautiful tap companies in the world, I believe. We've used zinc because I love zinc, because I think the older it gets. I remember being in a kitchen in France, and the kitchen was so old, like hundreds of years old, and
Really?
the zinc top was just like,
Wasn't it?
you had to touch it,
Really?
And it just, the more you use it, the more beautiful it gets,
Yes.
And
Sorry to ask about the cost of everything, Yost. How does it compare to stainless steel?
it is a little bit more expensive than stainless steel, but
a little
not-
bit more.
Yeah. And then obviously Caesar, and also it's stainless steel's great, but if it's dirty, it looks terrible. So you're constantly cleaning stainless steel.
Yeah. Yes.
So it's never unless no one's there and you've turned up in the morning and you go, oh, how good's this kitchen?
Yeah.
10 minutes later you go, oh fuck, I've got to clean stainless
Yeah.
steel.
Yeah.
It's not very practical.
No.
And so, and the kitchen, the carcass and everything was made. The carcass of the kitchen is made from sugar gum. Again, that same species that I discussed that can be coppiced. And then the rest is all from the macrocarpa that was harvested in Ballarat. We haven't laid the tile floor on this floor. We've just painted the magnesium board on the floor because we're worried that when we lift this up to move it to its permanent location, first of all, it'll be much heavier, but also, it might bend and the tiles might crack.
Oh, so you're not taking it apart to move it. You're just going to take it.
So this is one piece.
Ah, you take it in chunks.
Yeah,
Interesting. Cool.
3 bits.
It'll be, that's 3 pieces.
Yeah.
The stair bit. This is one.
Yes.
And then below is one.
Yes.
And then that's one. So it's 4 trucks.
Oh yeah, I can see where it's bolted there. The two steel sections.
Where? Show me.
Can you see in the steel sections where the louvre windows are meeting? There's a big bolt.
Oh yes,
And
I
there's
can.
2 big steel square sections.
Yeah.
That's
Yeah,
great.
got it.
That's awesome.
So how many bits?
So it's 4 trucks. It's
4.
1, 2, 5 bits.
5 bits.
6 bits. Sorry.
6 bits.
You can see Lockie made the splashback. It's made from skateboards.
I love that. Lockie, would you do all the skateboard decks?
I've got a recycling program at a skate park across the road.
Gotcha.
So when guys, they'll board and, they'll just trash them and
Yeah.
they snap them, they just chuck them in the bin. So
When
they
you go,
just put them aside. So every few months I just go just grab a stack of them.
That's one of the things I've loved about this as an artistic thing. It's one of the most lovely mosaics I've seen. Really, it's just great.
There's so many amazing colours in it.
Oh yeah,
when
colours, textures.
When you're cooking food and then you've got a camera on the food, and there's always a colour that picks up on what you're cooking.
Yeah, right.
And then
There's a few of these gold bits that just pop right out too with the light as it hits.
And then often a question is asked, Mila, why Mila? My uncle Case, so growing up in Holland, my uncle had a business where he sold second-hand Mila equipment. So we were brought up with, our washing machine, everything was Mila. Don't buy anything unless it's Mila, because it's the only stuff that's designed to last. So this is in the 70s, in Holland.
Yeah.
And so we migrated, and they didn't really have Mila here, but we came with all Mila gear, all second-hand gear.
Yeah.
So when they started selling it here, we bought it, and it's like a washing machine. Like when I moved out, when I was 20 with Jen, I found in the trading post a 17-year-old washing machine that we then had for another 15 years, and then after that I gave it to my brother. So it's like the idea that something is designed to last and be repaired.
It's still spinning.
It's still going.
Still going.
And so I ended up getting a relationship with them and met Marcus Mila and Zinkan. It's still a family-owned business in Germany, in Gütersloh. And the great thing about Mila is, no one knows this, but Mila was a dairy farmer, and Zinkan sold equipment to dairy farmers. So like the chair that you sit on when you're milking cows and the buckets, they're all wooden buckets at the time. And Mila had created his own milk churn, butter churn. And Zinkan saw it and said, this is in 1890 something, said, where'd you get this? He goes, I made it, I'm sick of them, they're always breaking, I made my own, And he said, well, do you want to make more and I'll sell them? And that's 50-50 joint venture, family business, still
Awesome.
going today.
Wow.
Now they've got hundreds of thousands of employees, and we went to Matt Stone and I went to the place in 2012 where they make the washing machines. There's 20,000 people working there, just where they make the washing machines.
Wow.
And they make them from scratch. And what's I love is the washing machine. The reason why it can spin faster, because all the farmers, especially in the red dirt, have Miele washing machines because it's the only one that gets the red dirt out.
Right.
And it's because it can spin faster than any other washing machine. But that's because it's so heavy, because they melt down all of the Siemens brakes in a foundry. So they buy all of the brakes from all the trains in Europe, and they melt them down, and that's the base of the washing machine. It allows the machine to spin much faster.
Wow.
And I just love that there's the whole fact that it's a closed loop, circular, designed to last, designed to,
and there's
everything
no
is
planned redundancy in it either. That it's made to break down so that you buy another one.
Yeah.
And I think that they were probably a bit worried about 10, 15 years ago that everybody...
5 years. Well, you've had a pretty good run with it, It's just, it's bullshit.
Yeah.
And I think more and more, as you're saying, paraphrasing you, more and more people are saying that is
bullshit.
And calling it out for what it is.
Yeah.
So if you guys want to come outside...
What about this sink? What's this sink made from?
It's
Is that
steel.
special?
No, it's not Frankie.
Is that steel?
It is steel.
Sounds
And
like it's
the reason why I love this
plastic.
finish is because, again, the same as stainless steel. It's like... it doesn't look dirty.
Yeah. Sure, that's steel. It feels
It's
like
definitely steel. Yeah. And it's
It's
coated.
the
This is
finish
like
that's on it. It's the coating.
powder coated sort of finish on it.
Wow. And so you're not constantly shining on. It's not like the spot that shows, like you were saying with stainless steel, that you're always buffing it up and going.
I just think I'm a big fan of, a home needs to be lived in. It doesn't need to be a trophy, and I can't stand it constantly having. If you're worried about, like for me, the places that I love the most are the places where they're not worried about whether it's clean or not. They're just worried about creating a great environment.
Yeah.
Rather than a finish, we have patination.
Yeah, the French are masters at it.
Yeah.
So it's that using materials that get better with age. That's that idea.
Yeah, the idea of a finish, like it's done. Like you finish the surface and then it doesn't change, and that's it. It's over. But nice surfaces don't do that.
And it's also maintaining that finish.
Yeah,
isn't it?
But this, you could use a different word for it, not call it a finish, call it a surface or something.
It's really interesting because I've forgotten his name now. Who did it? He's Swiss, And I called him and I said, I want to get a zinc top, and where are you? I'm at Fed Square, and I said, I'm on the river, but I'll give you the address. And he goes, I know where you are. And I said, no one can find us here. I know where you are. I spent 3 years at Fed Square.
I know where you are.
Doing all the zinc on zinc.
Oh, yes.
I spent a lot of time, and so he's got a car. So in Switzerland, when you got trained to do zinc, all the tools are in your car.
Right.
So he said, I would go to Italy for 2 days and do guttering and whatever zinc work needed to be done. So you don't have a factory in Switzerland. You get trained to have everything with you.
Right.
Yeah.
And so I did all that work at Fed Square.
Wow.
At Fed Square with my car. So
Wow.
every single corner and bend, it can all be done with the tools that he brought back with him from Europe.
Wow, that's really crafty. There's some real craft work there.
That's a great example of the patination that you're starting to get from that now, because
How
that's
beautiful is
that's got a few years on it now.
Yeah, 20 years, mate.
I love that building. I remember how a lot of people lost their minds when they built that, but I think it's just brilliant.
I agree. I think it's great in a lot of ways, but I wish that it addressed the river in a better way.
But I think that can still be resolved, though.
Yeah, I agree.
I think we need
Yeah.
to possibly maybe cut down some trees.
Yeah,
because
right.
the trees make it so dark.
Yeah.
And I think that if anything, I think this project has made them understand how valuable this real estate is here.
Yeah.
And, people love this space. They
Yeah.
love being along here. You can view the river, you can see the river. The mornings
Yeah.
especially are just incredible here.
Or we could just give it to Apple and they could build the pavilion onto the...
All right, Lockie,
I'm
let's go
a Jean
outside.
Provocateur today, sorry. You caught that one though very well. Okay, opening?
No, let's leave it.
Leave it.
What you see up there is an old Damascus tablecloth that my friend Stuart Russell printed my logo onto.
Oh, yeah.
And it's been repaired a few times, as you can see.
Wow, yes, some extra stitching in there. Yes.
And so what we've got here is possibly my favourite Australian design ever. It's called a wicking bed.
Oh, yeah.
And so there was a great Australian called Colin Austin, and he's supposedly Australia's first IT millionaire. He sold his business in the late 70s to Cisco Systems.
Right.
And he developed software that allowed people to manage water. And in 1984, when the famine was in Ethiopia, he was regarded already at this point in time as some bit of an expert with water management. And so World Vision said, can you come to Ethiopia and give us some advice on what to do, how we can make this more resilient, these food systems here.
Mm-hmm.
And he tasted the food and he could almost immediately see or taste that there were no nutrients in the food. So he worked out that they had massive downpours and then no rain. So when it rained, it poured and then
Yeah,
no
right.
rain.
Yeah.
So he worked out that the nutrients were leached from, a bit like soils up in the Daintree.
Yeah,
Right.
The nutrients get constantly leached out. And that's
Yeah.
why you need lots of organic matter to be breaking down constantly to get the nutrients back.
Yeah.
Yes.
So he got them to dig trenches, lined them with plastic, put rocks in them, and then filled them with soil. He created a wicking bed.
Mm-hmm.
And it was so successful that it was picked up by a couple of Americans as well, and the wicking bed, I think there's hundreds of millions of videos on how to make a wicking bed now. But it was Colin Austin who was the original inventor of the wicking bed.
Wow.
And he has a great blog. He's in his 80s now, but I follow him and his work intensely. He doesn't call them wicking beds anymore, he calls them gut biota beds.
What was it?
Gut, because he believes that biology in the soil,
It's the same as the stomach flora.
and when soil dries out,
Yes.
all the microflora die.
Yes.
Then you water it, and it has to start from nothing again. A wicking bed never dries out because the water. When you plant in a wicking bed, you water it from above for the first time,
Yes.
and then you put the hose in here,
Yes.
and the water gets wicked up from below.
Using capillary action.
Yeah, so you get no loss in evaporation,
Yes.
you get no loss in nutrients, and say, like now, in the next few weeks, I'll start doing that. So when we get rain, it'll lock the rain up. It won't waste the rain.
Oh, right.
So it's the ultimate zero waste system because you're not losing water from rain. You can
Why is
store it.
This is
the
over-
water coming out of it?
Overflow drainage?
Because this was too.
That's an overflow.
Because of all the rain, yeah. So
Yep.
if I have it like this, the water will be up to there.
Yep.
and the soil will just constantly pull that. So in January, when it's 40 degrees and hot, you only need to water that once a month, which is insane.
It's awesome.
That's insane.
Yeah.
Yeah.
Because it's got 100 litres of water sitting underneath, right? That the soil constantly just pulls up. And the top is dry, so you don't get spore mold formation, and you don't lose that top bit to evaporation either.
Yeah.
But the thing is, the soil has this microflora that is unbelievable because the soil's moist.
Yep.
So that's Colin Austin, and then these guys were making bumper bars and mirrors for Ford and car companies, and then when the car companies closed down, they decided to retool, and they've created these what's called biofilter. They're wicking beds they nest.
Yes.
Made in Melbourne, made from waste, 75% chip packets.
Yes.
And they're made from polyethylene as well,
Yes.
same as the gerbera pipes.
Yes.
I reckon these are unbelievable. I mean, you can see how much food has just grown out of these two alone.
Food cube.
We've taken the veggies out.
It's just extraordinary.
So these beans, you can see these snow peas.
Yeah.
There's beans already starting to grow there, see?
Yeah.
And then the other drums, I call them 44-gallon soil drums. They're old vinegar drums, and they're great because this building is reverse engineered, right? The soil on the roof is the foundation. It's sitting here. There's no foundation here.
That blew my mind when you first told me. I remember when I came and I said, how did Fed Square let you dig footings into the ground here?
Yes, you were saying footings.
Yeah.
So
Because this building is a big sail. It's 9.9 metres high at the back. So you can imagine it's a huge sail.
Yeah.
So it's got 35 tonne of soil that the engineer worked out needed to be on this building. So when we were building...
So all these are the things that anchor the building to the ground.
Yeah. So that idea came because I thought, well, everyone says that rooftop gardens are too expensive. Well, what about if you put less into your foundation?
Yes.
And put that money into rooftop gardens?
So in the same as a ship, we have the ballast. This is the ballast for the building. You can say it as another way.
Yeah. Yeah.
You say footings. That's the Yeah,
Uh-huh.
gotcha. Right.
Cool.
Yeah, so that's... and the other thing I wanted to talk about is the soil.
Yep.
So this soil is completely made from waste. It's basically, I mean, it looks very black and dark now, but it's made from composted organic waste collected from councils. It's also got scallop shells and oyster shells crushed in it, worm castings that the worms have been grown on waste, and the mycelium from the mushroom oil.
Yeah.
It's about 30%.
Wow.
So that creates this incredible foundation that allows the plants to thrive.
Yeah.
That's beautiful.
Yeah.
And so again, this is like all made from stuff that is mostly going to landfill at the moment, which is crazy. Then the other thing we've got here is another thing that I'm really
stupid.
Yeah.
Yeah.
Another thing that I'm really concerned about is the fact that we're depleting our oceans of seafood. So we're pulling way too much fish out of our oceans.
Yes.
And then there's this notion that there's a sustainable alternative, which is aquaponics, which is fish farms. The truth is,
What
that
do you
the fish
feel about fish farms? You're going to tell us. Sorry. Yeah.
Fish farms are the biggest users of wild fish. So it's more than half of the fish that are caught today in the oceans get ground up into pellets for fish farms.
Yes.
So it's insane. So we're catching wild fish, grinding it into pellets, and then somehow that whole concept is being sold as being sustainable.
It's bullshit.
It's bullshit. But I'm a big believer in microsystems. So a system like this, we had a lady from Northcote who's got a system identical to this, and she's had it for over 15 years, and she produces 50 trout a year.
Yep.
And I mean, this has got freshwater mussels in it as well. So
Oh, really?
Freshwater mussel.
They're natives, right?
yeah, and so these
That's
filtered,
awesome.
Oh, they're beautiful
They're
too.
gorgeous, pearlescent.
and they can live for up to 80 years.
Wow.
Really?
And
And they're not anchored.
and these mussels filter about 200 litres of water a day.
Wow.
Yeah.
So we lost some at the start, and it was because there wasn't enough fish and enough yabbies.
Right.
Oh, okay.
So
Huh.
yeah, so my dream is that every house would have a microsystem,
Yeah.
and we generate waste that can go into a worm farm. The worms get fed to the fish, and then the nutrients from the fish, feed these incredible plants here. So there's trout in here. I think we've got about 8 or so left. We had quite a few in there, but the point is we want to try and catch all the trout before Christmas.
Uh-huh.
because in January it's too hot for them. And then we
Right.
start again in March with fingerlings.
Gotcha.
And then in here we've got yabbies.
How many yabbies you got at the moment?
Quite a few.
Yes. You want to go in there, Lucas, and get a shot, or? The other thing that someone said to me, and it makes sense when it's stated that way, is the fact that, you know, when we have aquaculture and we're growing salmon,
Yeah.
and that's sort of like the equivalent of putting tigers in cages and like growing an apex predator
Yeah.
for food,
Yeah.
which seems crazy. He's a good looking boy, isn't he?
Yeah. These are the ultimate for micro systems. They're really happy here. They reproduce. You know, we've got lots of little babies in there. And yeah, they're quite productive as well. So you can have up to 70, 80 yabbies in a system like that.
Yes.
And so you could get a couple of yabbies every week. Same with trout. Like the idea is that you get a fresh trout every week.
Wow.
And you know, a system like
And
this,
they're delicious.
It's
3
amazing.
square meters produces that much. You know.
Yeah. What's your favourite dish that either Matt or Joe made with the yabbies?
On the grill, Matt made like when he just grilled it, and then they made this aioli, and we were just breaking it up, dipping it. We had like roasted radish and like root vegetables and mustard leaves, and we were just our hands were covered, and we were just feasting. You know, it was just all over
It's
us.
like a crab boil. Yeah.
So good.
And beer.
That's making me hungry.
Yeah, I'm hungry. What's this one?
Whoa.
Oh, here's Mama. Big Mama. Here we go.
So
Whoa.
see all the eggs there?
Yeah.
So they're
Wow.
on the point of hatching, really.
And how many survive in there?
Well, I mean, last year when this happened, we didn't realise that this had happened, and we siphoned the tank backs, and so I think most of the yabbies ended up down there.
Yeah,
in the
right.
garden. But most of them will
Because
survive.
do you almost have to like make a little enclosure so do the yabbies eat?
If we don't feed the yabbies, they'll eat them. But
Right.
as long as they're well fed, they're fine.
They leave them alone.
Yep.
This one's had a bit of a nasty
she's
run
lost,
in.
lost
Yeah.
a claw.
Oh yeah, it's
Alrighty.
amazing. It's amazing how quickly they regrow, though.
Oh,
No, they regenerate claws.
Oh yeah,
Of course,
yeah,
right.
very quickly.
that's
Yep.
awesome.
So yeah, that kind of showcases the whole system.
And the other thing that is just so obvious is just this fecundity that's around us, and what do you put that down to?
It's just you can't have nutrient dense food without nutrient dense soil, and you can't have nutrient dense soil without a closed system. So I
Right.
think one of the best quotes I've ever read was, "America is overfed and undernourished."
Yeah.
That was
Yeah.
1932. Weston Price made that
Aphorism.
observation
Yes.
after travelling all over the world and visiting Aboriginals in Australia, the
Yeah.
Hadza in Africa, Alaskan Eskimos. And he said that the Aboriginals had 17 times more zinc in their diet
Yeah.
and 12 times more calcium. And so then the nutrient density of their food, they ate between 400 and 500 different foods.
Yeah.
So they had much more biodiversity. That trip and that book was the inspiration for this house here. This house has hundreds of different foods growing. And because it's a closed system, everything goes back onto the garden. So there's nothing that leaves this site. So we've got the solution for nutrient-dense, healthy food where we live. I'm not a big, that's what silo was about. Deal with the waste where you generate it. Don't give it to somebody else to deal with. So closing systems, if you are aware of the waste that you generate, you deal with it and you reduce it as well. So, you know, this idea that we put it in the bin and we give it to someone else to deal with,
Someone else's problem.
yeah, we've got to move away from that.
Yeah, well, it was an international problem where we were sending it off to China, weren't we? Until
Yeah.
the Chinese said, actually, you're going to have to deal with that yourself.
Yep.
Which, yeah. It's
So
been a good thing.
I think we've pretty much covered all the elements here. I mean, there's a lot more, but, you know, I think trying to get that down to a
My
40.
head is spinning.
Yeah.
Like it really,
So,
really
yeah,
is.
we'll put this up as a YouTube video tonight, and
Yes.
Cool.
yeah, I'm excited to have these guys doing tours at the house, and to bring as many people through as we possibly can.
Yeah, and you can get hands-on and be a part of inhabiting this space, because I'm sure there's so much interest in this space, Yost. And I think the great thing about this is this actually gives you a chance to be hands-on with it, to feel what a zinc counter feels like, to feel what that magnesium oxide boards feel like, and
Touch the
just
straw,
just to be in this space. And there is one other thing which we haven't visited, is there's another story above us which has even more food, more ballast, anchoring down the building, and yeah, come on, be a part of it. We'd love to see it.